Hello and welcome to the module 4.10, and in this we will briefly discuss about the simple forecasting. So we learned about the time series basics and everything. Now you will learn how to do the forecasting, how to do the predictions using the time series data. So let's look at the basics, what you need to learn, what you need to know here. We'll go like in very brief. We'll try to complete each and everything that is required in this. Okay. So in the forecasting, we start from the again, like what is the main thing that we are going to learn? What is simple forecasting? So in the forecasting, we'll learn the name method, we'll learn the seasonal name method, what is drift, what is the overview of ETS exponential smoothing. Then we'll go for the evaluation matrix and the prediction intervals. Forecasting is very very simple. When you have some kind of data, you are making some predictions. When you have the known data, you are making some predictions. So by this you can compute, you can compute the accuracy of the forecasting, or the error that you will get in the predictions, how much you can rely if you are going for the predictions for September, October, November, December, and so on. So ultimately what you do is, like, you have a couple of months data. You can keep some of the data for the learning. You can use this some of the data for the learning to do the forecast predictions. These predictions you keep some of the data to check and measure the performance and evaluations. And then if you think that the forecasting or the prediction model that you are preparing is reliable, then you can use that for the prediction on for the months for which you still don't have the data. You are making some forecasting predictions for. Okay. So ultimate learning objective in the forecasting is build the baseline forecast is the first thing. Evaluate the accuracy is the second thing. First you will build the baseline forecast, and then you evaluate the accuracy with proper splits. Once you get the accuracies, then you understand the ETS components and then you communicate the uncertainty. What is the uncertainty might be having in your predictions? That is also very. First is the nave and seasonal nave. Nave and seasonal nave is, in the nave you simply do the forecasting for the data, but in the seasonal nave you do repeat the same thing for the last season value also. So you when you include the seasonal discompositional or seasonality information into your modeling, that means you are considering that for also for the forecasting. In the previous time series data we have learned this, the importance of the seasonality, importance of the cycling, importance of the normal trends, that sometimes you see seasonal specific variance also. So if you have seasonal specific variance and specific variance, those are like significant, then you need to include in the model, you need to include in your forecasting. Okay. You can use the drift method. There are n number of methods. You can just name it. You can just keep on trying. The ultimate purpose is, by using the previous data, how well you can predict the futuristic data. That's the ultimate purpose of the forecasting. Now, if you will ask me what method I will use, first I will report or I will submit, okay, this is my data and these are my predictions, and how reliable those predictions are I will make on the existing data that is already available that I haven't used for the training purpose. Based on that I will show my reliability. Now I will make the forecast for the months on which I don't have the existing data, and on that you can rely based on how much metrics, how much sensitivity, specificity, uncertainty I have reported using the predictions on the data for which I have already have the existing data but I haven't used for the training. So that's how you define. This is the ultimate forecasting rule. But you can use like the drift method, which extend the name method by adding the constant change over the time. So like if you are using the name method, simple name method, in which you are considering the values for making the forecasting, you will just add a constant change that is happening again and again. So for that formula you can use some of this. You will use the constant change here, and I think constant change is the h. We don't want to go into the details of the formula that you are never going to learn those formulas. You just need to understand the concept that in the drift method you are just adding a one constant change along with all the data points that you are considering. It is useful for the data with clear monotonic trends. If there is anything that is very much constant from like January to February, February to March, the specific change that is happening very constantly, so that constant is fixed, you can include that constant in your model for making the forecasting. Again, the drift method, in which you use some kind of constant, can't handle the seasonalities and the turning points. If you'll see any kind of specific variations due to seasonality or any turning points that are happening in the market or in the customer or in the marketing or everywhere, so those kind of things drift method cannot capture, because it will only include the constant changes. Then you go for the exponential smoothing basis. So exponential smoothing basis is a systematic approach to time series forecasting with increasing complexity. If you have high complexity in the data, a lot of changes based on the seasonality, a lot of temporal changes also, a lot of sudden changes also, then you definitely need the exponential smoothing rather than the drift method. In the exponential smoothing, you use simple exponential smoothing, in which you use the data with no clear trend or seasonality. You forecast are the weighted average of the past observations that we have learned, and we decay the exponentiality. You get this exponential smoothing parameter, which is alpha, which is greater than 0 and lesser than 1. So ultimately you are not seeing any clear trend or seasonality, but you are using the weighted averages. Then Holt's linear method. In Holt's linear method, it extend the simple exponential smoothing by adding the trend component. If you are seeing any particular trend apart from all the data and everything, and use trend for the smoothing, you use one for the level and one for the trend. Once you use this, you will have a two parameter. Now one is the alpha that you are using as a smoothing parameter, and beta you are seeing as a trend. So now instead of only using alpha, you are using alpha for the level and beta for the trend. Forecast include both the components, level plus trend, into constant variables. Then you use Holt winter seasonal method, which is also extend Holt's method by adding the seasonal component. So in the Holt linear, you added the trend component. In Holt's winter, you added the seasonal component also. So now you have the Holt method, in which the normal weighted data was there. Apart from that, you added the trend component there. Now you added the seasonality component also. It can handle both additive and multiplicative seasonality. Now you have the three parameters. Alpha is the level that we computed for the smoothing. Beta is the trend that you observed in the whole linear regression and used also. And the gamma is the seasonality. This requires setting the seasonal period, example 12 months of the monthly data. Here, like a smoothing parameter control the rate, each and every smoothing parameter control the rate at which the older observations are weighted down. Higher values give the more weightage to the recent observations. So those kind of weightage we have discussed, like what kind of observations, like current observations you would like to give high weightage, old observation you would like to give low weightage. So those kind of things you can do here. The ultimate is depending upon the data, what kind of method you want to use. Like if you would like to use the seasonality component, if you see, like, draw a pattern, see the data, if there is any seasonality pattern, include it in your model. If you see any particular trend rather than constant, use it in your model. Then you can easily decide which method to be used, whether it is a Holt method or Holt filter seasonal method. You can quickly use and explore. Okay, now ultimately ETS framework, in which you discuss few important things. First is the error, how random fluctuations affect the label, be it additive or multiplicative, be it including the seasonality or everything. But estimate how much fluctuations you can see, that is the error. How much fluctuations you can afford in your model, in your forecasting. The trends, there will be either no trend, or there will be additive trend, or there will be additive damp trend. So learn about the trends, learn about the seasonality. Either there is no seasonality, or there is a additive seasonality, or there is a multiplicative seasonality. Like when you look at the data, you will come up the conclusion there is any three of the information. Either you will come up with the answer of there is no seasonality in the data, or there is a additive effect you see, or the multiplicative effects you see by include the seasonality information. So ultimately, for the trends, for the error, okay, for the seasonalities, you will just provide these information, whether there is a trend, if there is a trend, how it looks like, if there is a seasonality or no seasonality, how it look like, if there is any error, whether it is additive or multiplicative, you need to see those random fluctuations also. Notation examples you can provide. ETS, for ETS is AAM, is the additive error, additive trend, or multiplicative seasonality. If we are providing the information like this, ETS, which is error, trend, and seasonality, and you can see the error is additive, the trend is also additive, and seasonality is multiplicative. So that's how you reported your complete framework. And just based on this, you decide which model to choose for the forecasting. Automatic selection you can do by information criteria in AIC BIC to choose the optimal model. And this framework will help you to select the right and appropriate model for the forecasting. Now, how you will evaluate the forecast? Again, the accuracy matrices, you will use the mean, absolute error, intuitive sales. RMSE personalizes the larger error more heavily. Then you can use MAPE, percentile error, sales independent, which is sales independent. You can use MAP. There are a lot of terms that you can do. These RMSEs, MAP, MAE, mean absolute error, you can compute. If you remember, we discussed here. So you are using this data 1 2 3 4 5 you are using this data 1 January, February, March, April, May, or May data to make the forecast. You are keeping the data June, July, August with you to check the errors and everything. And these data for June, July, August, you are predicting using the previous data, doing the forecasting model that you will use, any model based on the trends and patterns you are seeing. This is forecasting. Now you'll see the differences at each, at July, at June, July, and August. How much is the mean standard error? How much is the RMSE? How much is the MAP? Those kind of things you will calculate and report that. Based on that, it will be divided where the forecasting model will provide a good enough information for the data or not. Then we go for the validation approaches, which is again test train split. This is simple but limited. You can do cross validation also, five-fold cross validation. You can do ten-fold cross validation, or like you can divide the data here very carefully. We discussed the test data will be used to check the performances, and train data will use to do the forecasting on the data, the test data which you have the existing values also to check and make the predictions. Then you can use the rolling or regional cross validation. Multiple test window you can keep, and you can test it again and again for multiple test windows, and you can then come to the conclusion of the mean absolute error and the RMSEs and MAP. You can do comparison to the naive baseline essentials. Ultimately, the historical accuracy is not equal to the future guarantee. This is not the exactly what you are seeing, what you have seen in the past will be the same in the future, but at least you can get a good guess, a good prediction with less uncertainty and with more accuracy, and that is the ultimate aim of the forecasting. Forecasting uncertainty is very very important, which you communicate when you're presenting your model. You are communicating that in this particular forecasting model there is some kind of uncertainty, which communicate the risk in the predictions that you are going to make. So prediction interval communicate the range of likely future values. Intervals widen or for longer forecast horizons increase the uncertainty. When you are providing the range, me like for the November, December, and January month, that your sales will vary from $1,000 to $100,000. So that means the range is super high. It is increasing a lot of uncertainty. The range or the intervals should be lower to provide more certainty to your predictions, so that more people can trust. Less risk will be associated with it. So those kind of things you need to communicate. Typically, you report 80%, 95% intervals to quantify the uncertainties. You can combine with the scenario planning for robust business decisions, like whatever uncertainty you are getting, whatever the accuracies or errors you are getting in your forecasting, the business can make decisions based on that, whether they can tolerate those kind of uncertainty in the business decisions, or the models needs to be refined. Any other covariate or co-features like seasonality and all those things we discussed should be incorporated. Any other constant variables should be incorporated in the model to make little bit more reliable prediction, little bit less intervals, little bit less longer horizons, little bit less uncertainty and higher accuracies and all those things. You can give the example of the seasonal noise and the Holt Wilter noise. You can just split the data, fit both the models. You can, what you can do, you can take the data from January to December, let's say, fit both model. Seasonal naive model you can fit like forecast, include the seasonal information for 12 months monthly data, calculate the alpha we discussed, compute the beta which is a trend, compute the gamma which is seasonality. So those three things we have discussed, all three parameters you include, and utilizing these all three parameter you can do the forecasting. You can compare the performances can be compared for, let's say, seasonal naive you did, and you are getting MAP, you are getting for Holt Wilter you will do MA, you are getting MAP, you are getting. So lower the values shows the higher the performances. So if the lower the values you are getting in the Holt Winter method rather than the seasonal naive, that means the data of the Holt Winter parameter is performing well on your data than the seasonal naive. So you can do quick modeling and get the performances in terms of MAE, MEP, and just check. The lower the number is, better the model is. And definitely the whole winter, if you remember, the whole winter method was the method in which we were including, apart from doing the simple exponential smoothing, we were including the trend component also, which was beta here. Okay, so by just including the trend component, if you're the error rate which we are getting in simple naive, it might be improved. Okay, visualize and select the model. Both the models you have done, you can use the simple plot for both the methods. Direct, you can do the direct comparison, and you can provide, okay, including the trends in the whole filter method, we can reduce the error a lot. So this can be our best method. You can plot the 95% prediction intervals for both methods, show the better performance which model is showing, and then select which method you are selecting ultimately for the forecasting. Very important. Then the method selection guide. Again, you use the naive when data has no clear trend or seasonality. You will use the naive method. If there is no trend or seasonality, you will not include anything. You will just use the constant weighted average. Then seasonality naive. If you have a seasonality in your data, strong seasonality, you see the season specific changes, you will include it. You can use simple moving average that we discussed, which is volatile data needing some smoothing with no trend. And then drift method. If there is a clear, consistent linear trend without seasonality, if you're seeing a constant change across time, then you go for the drift method. So ultimately, you need to decide from looking at the data, make a quick plots, see the data, and decide which method is appropriate for you, which method will be more appropriate for modeling and forecasting to make the reliable results. You can go for the advanced methods like simple exponential is a noisy data, no clear trend or seasonality. You can use the Holt linear we discussed, Holt winters we discussed, and the ETS model in which you do automatic selection when patterns isn't obvious. You feed the data, the obvious pattern you cannot see by the naked eye. Do some mathematics, do some statistics, find out the trends, find out the patterns. If there is any statistically significant trends, patterns, along with the seasonality, along with the constant data, along with the, then use those in your model before making the forecasting, before doing the predictions. Ultimate summary: start simple, use naive and seasonal naive method first, make a baseline, see the trends, see the patterns, then go for the complex models. Okay, benchmark the performance, always compare the advanced methods with the previous methods. uh, Report the metrics, discuss which method is performing better in terms of the error rate that they are producing, validate properly, do the rolling origins, hold out, test set, train set, hold out validation, use specific windows also to cover each and every data point, respect the time and order, do proper validation before doing any kind of performance reporting. Then at last, the most important thing is communicate uncertainty. Always provide prediction intervals, not just the points forecast. When you provide the point forecast, provide the intervals also, how much this forecast can deviate in the upper range and the lower range. We discussed the interval is lesser, the confidence is higher, uncertainty is lesser. So keep those things in the mind. Quick check: if you have a time series data with strong seasonality but no apparent trend, which forecasting method you will use and will be appropriate for the simple baseline will be seasonal naive method you will use, because it has only seasonal trend but not the any other trend that you can include here. I hope this is clear for you. Let's quickly recap this, let's quickly wind up this, and then we'll go for the hands on. We'll quickly discuss how you do the quick statistics in Python. In also in one of the class in the Python module 5, I have taken a complete section for the doing the statistics in Python, and there I have discussed each and everything in detail. You can go to the module 5 section and there check the statistics in Python in detail. I will briefly cover here just to give you some of the examples what we have learned today. For each section, just one example, and we'll quickly recap it. So see you in the next module.